In the Olympics, gymnastics is one of the most popular sports and certainly one of the most interesting to watch. Athletes performing at gymnastics competitions push the very limits of what their bodies can do. They also push the limits of physics. In this video, we will show how physics is applied in gymnastics.
Before the gymnast starts doing this exercise, she has a potential energy since she's not moving. When she jumps to take the bar, she's applying Newton's third law. With every action, there is an opposite and equal reaction. She will apply a force to the springboard, which will exert the same force to her to make her go up. When she's holding the bars, we can find a specific friction force between her and the bars. When the gymnast is stretching her body, that is what we call linear momentum. Linear momentum is a vector quantity defined as the product of an object's mass and its velocity. Then, when the gymnast pulls her knees up, she is creating an angular momentum. The angular momentum of a rigid object is defined as the product of the moment of inertia and the angular velocity. It is really important, the center of mass during this whole exercise. During this motion, there are two forces acting against the gymnast: resistance and friction force.
Before the gymnast starts doing this exercise, she has potential energy since she's not moving. The gymnast will then start running very fast, increasing her velocity to gain more momentum. Momentum equals to mass times velocity. The harder the trick, the more momentum needed. Then, the gymnast will apply a force to the springboard, which will exert the same force on her. Here, she's applying Newton's third law. For every action, there's an equal and opposite reaction. After the gymnast hits the ball table, she will experience projectile motion, which is the horizontal movement of an object in the air where the only force acting upon the object is gravity. Her body will be in motion until gravity takes over. A force is not required to keep an object moving, it only requires to maintain its acceleration.
To do a handspring, the person must stand straight up. While doing this, the gymnast has what is known as potential energy. She will continue to be at rest until other forces act upon her. Next, the gymnast needs to go on a sitting position. While sitting, the athlete should keep shoulders directly over hip and knees directly over the ankles, achieving a 90-degree angle in both knees and ankles. While she is doing this motion mentioned before, she is applying torque. Torque is a measure of how much a force acting on an object causes that an object rotate. Then the gymnast must push herself off to the ground, therefore creating kinetic energy and applying Newton's third law. With every action, there's an equal and opposite reaction. The force then carries the gymnast backwards, creating projectile motion, which is the horizontal movement of an object in the air, where the only force acting upon the object is gravity, until she lands her hands and creates a force against the floor, in which the floor will exert the same amount of force to act upon her and making her stand in her feet. Then the gymnast will go back to potential energy. This process will continue until the gymnast stops.
Gymnasts use physics every day. If a gymnast realized how much physics went into every motion, every back handspring, every mistake on the bars, they would be better equipped to handle the difficult aspects of gymnastics, since every single movement can affect the result of the exercise.